The pointy end is up, the flamey end is down. That is a very important thing to note when you're about to launch your rocket into space. But the other thing that I love talking about here is those clouds. Everyone always still asks about why are there those clouds, or why is that smoke pouring off the rocket?
9 Merlin engines in the first stage are chilled. They're ready for flight. The LOX loading will complete on that second stage in just a few seconds. Once that occurs, you'll start seeing more of this white clouds venting.
So yeah, so the white clouds, that is from liquid oxygen. Liquid oxygen is extremely cold. SpaceX actually chills it beyond freezing, almost to becoming a solid. I believe it's like minus 207 degrees Celsius. And when you do that, liquid oxygen, to take oxygen as the gas like we know it, to compress it down into a liquid, you have to chill it down a lot. It's extremely cold. So what you have to do, and in order to, so the cool thing is it becomes 1,000 times more dense. You can fit 1,000 times more of your oxidizer into the rocket when you chill it down into liquid oxygen. But of course, it's warm. It's down there in Florida. So as the ambient air temperature warms up the liquid oxygen, it does boil off and it becomes a gas again. And so they vent it out. But it's still really cold because the phase change is like it's around a minus 180 degrees Celsius. So the gas coming out of there is still really, really cold. So it comes in contact with the humidity and the water vapor in the air and becomes these little clouds of condensation. So if you were to go and touch this rocket right now, especially in those parts that have the cold, okay, here we go. We're in startup mode. But it'd be so cold your hand would stick to it. So just keep that in mind, that it's extremely cold on the outside. It's about to be extremely hot.
Go for launch.
All right. They're going for it, guys. So we do have
30 seconds.
We do have telemetry, but it might be the wrong telemetry.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Yes!
And liftoff of Falcon's first East Coast polar launch, Ola, Argentina.
We're now 40 seconds in the flight. Falcon 9 has taken off. It's cleared the tower, and we're currently throttling down to prepare for maximum Q. That's the point of maximum aerodynamic pressure. It's at 1 minute 12 seconds.
So we will be putting up the simulated telemetry of the first stage, which will be really cool because it does basically go backwards, don't forget. So we'll see that here in a second. Wow, punching through the clouds there.
Vehicle has reached maximum aerodynamic pressure.
You've heard it. We've reached max Q. At this point, the loads in the vehicle become less and less as the atmosphere gets thinner. We're now able to throttle those Merlin engines back up. And at its maximum power, like right now, the vehicle consumes more than 700 gallons of fuel per second. All's looking good with our first stage's trajectory. The next couple events, there are 5 events, one after another. First, our main engine cuts off on our first stage. The stages will separate. Our first stage will then flip around to begin its landing attempt. The second stage's Merlin vacuum engine will ignite for second engine start 1. The first stage's boost back burn will start. It's one of 3 burns to help us land. They occur one after another in about 15 seconds.
Here we go, baby.
And this is that first polar orbit. If the clouds, you can see through the clouds here, you'll see some unique views that you haven't seen from Falcon 9 over Florida.
Yeah.
And we have Miko.
Stage separation confirmed.
All right, and here's our simulated telemetry.
In the ignition.
Looks like it's a little bit ahead.
All right, all of those events happen successfully one after another. This boost back burn, it'll last about 40 seconds.
I love that.
As you see on the left-hand side of the screen, on the right-hand side, you will see our second stage carrying those 3 satellites to orbit. And coming up next in about 20 seconds, that boost back burn will end, and then we'll have our fairing deployment.
Oh, baby. Haven't seen a return to launch set landing in so long. That was a short boost back burn, too. It must be a really lofty trajectory. Did you say? I thought you said 4 seconds.
One of those,
that was longer than
first landing burn, the boost back burns has successfully ended. Our 2 fairing halves will now jettison to expose the satellites to space.
All right. There comes the grid fins.
You see the first stage is already being a turnaround, and you can see the nitrogen from our attitude control system helping guide it back.
Fairing separation confirmed.
Good.
There you see our 2 fairing halves have jettisoned. You can even see them in the background there on our MVAC engine, and you can see them from land too. It'll take us some time to get those
telemetry is wrong.
to come back
Sorry,
down. We'll
guys,
keep
I think
posted
I
on the
messed something
update.
up. Yeah, that was the wrong telemetry. Andrew, just to
We are
confirm,
T plus 4 minutes and 13
is,
seconds into flight. Everything is
stage
looking
1/2
great for
altitude,
tonight's
right?
mission. On the right-hand side of your screen is a view of our second stage, specifically its Merlin vacuum engine. We also call it MVAC engine for short. It's currently in the first of its 2 planned, first and only planned MVAC burn. The first burn should last for about another 4 minutes. On the left-hand side of your screen is a view of our first stage looking downward. It's continuing to fall back towards Earth. The next milestone for the first stage is its first stage entry burn. Falcon 9 needs to execute an entry burn to slow itself down before hitting the dense parts of the atmosphere. Without this second burn, relying on the atmosphere alone to slow Falcon 9 down would put unnecessary strain on the rocket. That entry burn is coming up at T plus 6 minutes and 10
Second stage
seconds.
is following nominal trajectory.
Sorry,
Acquisition
guys,
of signal, South Texas.
You may have also noticed that we've deployed our 4 hypersonic grid fins.
guys.
Those are the honeycomb-like structures that you see on the left-hand side of your screen. They help to guide the first stage back during descent by moving the center of pressure on the vehicle. Again, those bursts of gas are nitrogen. It's absolutely normal, and those help to orient the rocket during its descent back towards Earth.
Look at it. It's almost going to be flying back into
We're
its
about
exhaust
20
plume.
seconds away from our second burn, the entry burn.
Stage 2 FTS has safed.
Look at that. That's awesome. I've never seen it come this close to its own plume before like that. I love this. Here we go.
Stage 1 entry burn startup.
And 3 Merlin engines have relit and are currently slowing the first stage down before it hits those dense parts of the atmosphere.
I wish we could show you our telemetry now because it slows down a lot. It slows down to more than half on some of these missions.
Second stage on the right-hand side of your screen is continuing to perform as expected.
Stage 1 entry burn shutdown.
All right.
And that is our second burn completed. And as we mentioned earlier, we are going to be attempting to recover this booster back at land on landing zone 1. The first stage has one more burn left.
Is saved.
That is the landing burn. It begins just before we
Second
touch
stage
down
still
and
following
provides the
nominal
booster with
trajectory.
a soft descent before we land.
They must be right on target. Look at those grid fins aren't even hardly pointing
During
at
this
all.
period, the landing legs will also be deploying. You might be able to catch it right before we touch down. They're stowed at the base of the vehicle and made up of state-of-the-art carbon fiber and aluminum honeycomb.
Stage 1 transonic.
Come on, baby.
You see the
Oh,
cape
look at
getting
those
closer
views.
and closer. What a cool view.
Oh, that's
The
awesome.
first stage is passing through the cloud layers right now.
Yes. Thank
Stage
you
one
for
landing
not
startup.
hitting the NROL satellite
And
too.
here comes Falcon 9 attempting its 4th landing.
Oh man. Yes. Yes. It's gonna be a bullseye. They make this look too easy.
Stage 1 landing leg deploy.
Wow. Wow. That is a shot right there.
And you could not ask
Stage
for
one
a
landing.
better landing
Wow.
than that. Falcon 9 has landed once again. That is number 4 for this first stage booster and the 58th overall of an orbital class rocket. What a way to start off tonight's mission.
Yes.
The second stage and our primary mission are still continuing and remain healthy. The next milestone for the second stage is second engine cutoff 1, also known as SECO 1, and that is coming up at T plus 10 minutes and 5 seconds.
That might have been
During
one of the
the
cooler
second
ones.
engine cutoff 1, we'll be shutting down the second stage's MVAC engine. And as we approach this period, we'll be listening very closely for 2 callouts. Verification of SECO 1 and then confirmation of a good orbital insertion. Both are going to be critical to ensuring that we deliver all 3 payloads to their intended orbits tonight.
That was I don't know, that was awesome. And that shot, by the way, the launch pad you can see in the background, that is New Glenn's launch pad.
And while we're waiting for that period, some fun facts. The engine you see on screen can produce over 200,000 pounds of thrust. The second stage is currently traveling at over 20,000 kilometers an hour. At those speeds, you could travel from Los Angeles to New York in just 12 minutes. Very, very fast.
Yes, please. That was great. That was fantastic.
We're about 20 seconds away from second engine cutoff 1.
Gosh, I love those return to launch site landings. And get ready, here comes SECO.
And we have SECO.
Yep.
And
Wow.
the second stage Merlin vacuum engine has successfully had SECO 1.
Look at that.
Nominal orbit insertion.
And that is the other
Wow.
call out we were waiting to hear on. A good orbital insertion. In
Yes.
just about 3 minutes, we will have the first of our 3 deployments. Until then, we are going to take a short break and be back around the T plus 13-minute mark for the deployment of the SAOCOM 1B satellite.
That was great.